Okay. Last chapter of online advanced functions. Woohoo. Maybe. Who knows what happens next year. Okay. A brand new topic, sort of. We're going to base it off exponential functions, which you learned quite a bit of in grade 11. And there's two main ideas. You have to understand what an exponential function is, and you have to understand what an inverse is. If you understand those two main concepts, then logarithms is just kind of a new language of mathematics for us, but the arithmetic is not overly difficult if you understand exponents. This is a nice way to end the course, get out a trig, which was kind of some more heavy math, and finish with a bang. So we are going to do 5 of the lessons from this unit. I believe it originally had 7 or 8, but due to time restrictions and the fact that you're half teaching yourself, we've trimmed it in the way we have. So what I want to look at is, this is what your note looks like. It's pretty much all filled in for you. There's a couple examples that you're going to have to watch the video to get filled in. But what I want to do is kind of review the two main concepts we have to understand before we can get into what exactly a logarithm is. So first of all, I just want you to remember what an exponential function looks like. So there were 2 different types of exponential functions. One that was called an increasing function. And basically that meant as your x values are getting larger and larger and larger, what's happening to your y values? They're getting larger. Or decreasing functions, as your x values are getting larger, your y's are getting smaller. Obviously that's a lot of review from chapter 1 and 2 in this course. Yes?
Are you done your video yet?
No, I just started another one.
What?
Why?
You goofball.
Do you need help?
No, I just want you to see our floor. It's so big.
Okay, I'll come in a minute.
When you stop the video?
When I'm finished. I'll come in 10 minutes.
Okay.
So a couple things to remember. There was an asymptote that sat on the x-axis that meant it was going to approach but never touch. There was a specific y-intercept of 0, 1 that they all went through. The larger the base got, remember they all had different key points, the larger the base got in an increasing function, and increasing functions all had a base of greater than 1. The larger it got, the steeper it increased, the faster it increased. Same with the decreasing functions. Decreasing functions are all have bases between 0 and 1, and the smaller the base, or the larger the denominator, the steeper it got. So if you had like 1 over 10x, 1 over 10 to the x, 1 over 100 to the x, it would be steeper and steeper. So just remember generally what those looked like to begin with. Okay, now the next thing we want to remember is, what is the definition of an inverse? Well, an inverse was a reflection of the diagonal line. So if I took this graph, I've just taken the y equals 4 to the x, and I just folded it over, where would it land? So the idea, remember that you're just interchanging x and y values. So if this is the point 0, 1, then this has to be the point 1, 0. So that's sort of some important ideas, the interchanging of x and y. If that is 0, 1, then you flip the x and y, and this is the point 1, 0. And you continuously do that, and then if you folded your paper, they would land exactly on top of each other. Well, this inverse function has a special name. So these ones are all called exponential functions. The inverse of an exponential function is called a logarithmic function. And we haven't learned anything about logs yet. We actually did questions involving inverses of exponential functions, but we used trial and error in grade 11 to solve them because we didn't know what a logarithm was yet. Now this is where it kind of gets a little tricky, and only until you understand the language of it. So if I had this as my original function, that's this one right here, y equals 4 to the x, and I wanted to find algebraically what is the inverse. Last year we would have said, okay, follow these 4 steps. Step 1, interchange x and y. That means wherever there was a y, we put an x. Wherever there's an x, we put a y. We get to this point. And then it would say solve for y. Well, how do you solve for y when it's in an exponent? We never knew how to get past that point. Well, what I'm telling you here is they created, mathematicians created a special way of writing exactly what this is. And they basically wrote it like this. In order to solve for y, we use something called a logarithm that can be written like this. Y is equivalent to log base 4, whatever your base is here, goes down there, starting over as a subscript, to the x. And the way you would read this is 4 to what power y is going to give me an answer of x. So 4 to the exponent y is going to give me an answer of x. But it's written in what looks like a really funny way right now with something called a logarithm. And you're like, what's a logarithm? A logarithm is just the inverse of an exponential. Okay? So what you're going to have to be able to do is go back and forth between what is called exponent form and what is called logarithmic form very easily. So I'm going to leave this down here. This leaves it all up there without numbers. There was a 4 in this, but this is in general. If x, what your answer is equivalent to some base a to the power of y, then this y is going to be equal to log base a, log of x to the base of a. That's how you read it. Log of x to the base of a. So whatever number here is always your answer. This is always your exponent, and your base remains your base. Okay, that's the part that's easiest. The base, the subscript here, remains your base here. So that looks confusing. This looks confusing. Once we start applying it, I promise you'll get used to it very quickly because we're doing a whole unit based on logarithms. So I'm going to erase everything but this little box in the bottom. Okay, so if you turn your page over, there's a couple more examples. So the first one says, write the inverse of f of x equals 4 to the x in log form. So really this is saying y equals 4 to the x. So you're just applying, this is just what we just did. The base remains the base. This is your answer you're looking for. So what happens is the x goes over here, log gets written, the 4 remains your base, and the y goes here. So you're basically saying 4, oh wait, I did it the wrong way. I thought I was doing inverse, sorry. Y equals log 4x. Oh, never mind. I just erase. I didn't even write the question down right. We have to find the inverse. Okay, do that again. Write the inverse of f of x equals 4 to the x in log form. Okay, that makes more sense. Okay, so if we rewrote this like this, that's the original question. For the inverse, when you're getting it into inverse form, remember you're interchanging the x and y. So anywhere you see a y, you put an x. Anywhere you see an x, you put a y. So this is now the inverse. In order to put it in log form, the way you want to think of it is you want to look down here. X equals a to the y. Equivalent in log form, the y comes down here. Logarithm. The base stays the same. This was the base of the exponent. It's the base of the logarithm. And the x goes here. And really what this is saying is 4 to what power y is going to give me an answer of x. So this is the part that you have to be good at. This idea, you could have got to this in grade 11. That's just finding the inverse. But now changing it into logarithm form, that's where you're going to come in. Okay. If you look at the next examples, it becomes a little bit clearer. We want to write y equals log 3x in exponential form. Okay? Really, make sure you identify that that's a little bit lower. Well, y equals 3 log x in exponential form. The base remains 3. We're saying 3 to what power y is going to give me an answer of x. Now, if you like it better, you can write the x out here, 3y. So you're going to have to practice going back and forth. Okay, now example 3, and this is really where it starts to make the most sense because you can see it in action. Example 3 has numbers everywhere, which makes your life easier. So you actually have to solve these. So there is log 2 to the 8, log 3 to the 81, log 7 to 1, and I'll do d over here, log base half, log of 132 base half. Okay, So really what's happening here is if you look at this definition over here, this, you're looking for this answer y, basically. Log a x. So this is saying log of x to the base a. Well, this is log of 8 to the base 2. If I transform this back into exponential form, this is really saying 8 equals 2 to what exponent? Okay, 2 is the base. 2 to what exponent is going to give me an answer of 8? That's exactly what that's asking me. So obviously, because you made it all the way to grade 12 math, in your head you can say, well, 2 to the 3 equals 8. And that's how you figure out what this is. So this is the base. 2 to what power will give me this answer? So you do the same thing here. 3 to what power will give me 81? That's what you're thinking. This is really just in your head. Okay, thought bubble. Okay, what are you thinking? 3 to what power gives me 81? 3 to the power of 4. Okay, so you had to recognize in your head 3 to the power of 4 is going to give me 81. Same thing here. The base is 7. 7 to what power is going to give me 1? 7 to the power of 0. Anything to the power of 0 gives you 1. Okay, and the last one, 1/2 to what power gives me 1 over 32? And you would have to know that 2 to the 5 is 32, and that's going to give you the answer there. Okay, so that's the way you should be thinking. You should be looking at these and saying, this is the base, this is the exponent, that is the answer, written in logarithmic form. You need to practice these quite a few times in order to get a little bit better. There's a question for discussion on the end that says, how could we sketch the graph of y equals log x base 3? Well, it's the inverse of y equals 3 to the x. So you know what y equals 3 to the x is. Pick a couple key points, interchange the key points, and then you have the graph of the logarithm. Okay, that's important because in the next lesson, we're going to be doing transformations. So I'll look at it closer in the next lesson because that's where we want to get it. Right now, all you want to be on top of is understanding how the logarithmic form is related to the exponential form. If you can go back and forth with sort of example 1 through 3 right here, then you won't have any problems with this homework. Okay, good. I must go see the fort.